Example 3.7 that says a car suspension spring has a stiffness. So the spring has a stiffness. This is the car. The whole mass is acting like a car. So the spring has a stiffness. This K is the symbol for stiffness. K is symbol for stiffness, which is 16,000 Newton per meter. And it is under undeformed condition at position 1. So if you see this position 1, this state is undeformed. Spring is in a equilibrium condition. If a mass of 50 kilogram is suddenly released, so this mass M, I'm using the same diagrams for this example, 50 kilogram is suddenly released to that spring, contracts to the new position, determine the deflection of the spring using the energy conservation method. So you have to find out the deflection in the spring using the energy principle. So let us complete this equation. I would say advise my students do each part one by one. Find out kinetic energy position 1, potential energy at position 1, strain energy, then you will not be confused. So let us write down each energy at for on the left. Let's complete the left hand side first. What is the kinetic energy at 1? It is 0. And what is the potential energy at 1? It is that the datum is located at position 1. This is 0. What is the strain energy? It is again 0. It is undeformed. That has been mentioned, that this is undeformed spring. And potential energy, external work, remember there is no force acting on it, so external work is 0. All the left hand side terms are 0. Right hand side terms, kinetic energy, it's 0 again, because the mass is released and it becomes stationary at position 2. It becomes at rest at position 2. How about position 2? The potential energy at position 2 minus mgh. So if you solve for this, that h we have to find out. Let me change this h to x, because that's what we are considering as an unknown, mgx. How about the strain energy? Would it be would the spring be under compression or tension at position 2? It's under compression, so we will assume the convention is for the compression we use positive, tension we use negative. So it is half kx squared. So let us plug in all these values in this equation. So left hand side is equal to 0 is equal to minus 6 minus, so can you solve for this please? Minus 50 times 9.81 times x plus half 16,000, yes, 16,000 times x squared. So what do you get for x? It should be 0.0613 meters.